So in summarizing what we just found, we found that the sum of the measures of the interior angles of a convex, so that's being the important part, convex n-gon, is just going to be n minus 2 times 180. Alright, so that's going to be an important equation that we're going to work with throughout this section. And then also an important part, since later on our focus is primarily quadrilaterals, we just want to make note that for a quadrilateral, so a four-sided figure, the sum of those interior angles is going to be 360. Okay, that's going to be really important later on. We're going to work with quadrilaterals quite a bit. Alright, let's take a look at using this equation for any different type of polygon. So for instance, an octagon. An octagon is just an 8-sided figure, so n is equal to 8 in this case. We want to find the sum of the angle measures for that polygon. So all we got to do is just plug it into the equation that we have. I'm going to replace n with 8. So I got 8 minus 2 times 180 degrees. Alright, so we know for that, really what you're doing is you're taking 6 times 180. And we're going to find that for an octagon, we add all the interior angles up, we're going to get is 1,080 degrees. Okay, so that will be the sum of the angles for that one. For a nonagon, and this will be the last one I expect you guys to kind of recognize in terms of a term. Other than that, we'll give you the actual number for it. Nonagon is just going to be a 9-sided figure, so n will be equal to 9 in that case. So same thing as before. We can just take that to the equation and we can figure out what the sum of the interior angles is going to be. So I got 9 minus 2 times 180, which we know after we simplify that, we really have 7 times 180. And the sum of those angles, we get 1,260 degrees. Alright, so if we add all the interior angles of a nonagon, a 9-sided figure, that's what it'll add up to. Now you can imagine this stuff's going to be useful later on because we're going to solve for some of the unknowns by knowing how many degrees are there in that figure. Alright, so for a 22-agon, so this would be the type of thing we're not going to just use a name for. We know that n obviously is going to be 22, and we can go ahead and we can substitute that into the equation. Alright, so we got 22 minus 2 times 180 degrees. Alright, that will give us 20 times 180, which is a total of 3,600 degrees. So this equation is going to be useful. Without even drawing these figures, without drawing to see how many triangles we're going to get, we're going to know automatically how many, what the sum of the interior angles is going to be.